Good morning, everyone.
Morning, sir.
Yeah,
Morning, sir.
good morning. The days are going by, and it seems like people are getting lazy to get inside the class. It's online. You don't have to go to school. You don't have to dress up to uniform and attend school classes. You just have to come online. And still, so many people are so late. Why? How easy could life be? Now, so today we're gonna discuss about properties of determinants. Okay, so now there are basically 6 properties of determinants, and this one we are gonna have the property number 1. So we'll start with property number 1. So what we have is the value of the determinant remains unchanged if its rows and columns are interchanged. So one thing, row and columns are interchanged. We already heard this one before. Row and columns are interchanged where? When we find the transpose of a matrix, right? So in here, when we interchange the row and column, the value of the determinant will remain the same. Everybody remembers how to find the value of the determinant of an order 3 matrix, right? So here, there is a matrix of order 3. Clear? So first thing, I will find the determinant of A. And it's easy. I see row 1 has maximum number of zeros, so I will be doing expanding along row 1. So first thing, this is A11, so it will be A11 will be positive, right? So positive, so it will be plus, so I get 1 into, then what I will do, I will cut this, and what I get, 4 9s are 45 minus 8 6 are 48. So I get the answer as minus 3. Am I clear? Okay. So this is how we found the determinant. And this is what a determinant of this matrix. Now we see if I interchange the row and column, and let us see what happens. By the property, the determinant value will remain same, right? Now you see this is what 147 column 1. Now it becomes the row. 058 column 2, it becomes a row. 069 column 3, it becomes a row, right? Now let us find the determinant of this one. Now in here, in order to find the determinant, I will expand along column 1 because it will be easy because it has maximum number of zeros. So that will be equal to what? Again 1. Why? Because minus 1 to the power 1 plus 1. I don't have to write because I already know 1 plus 1 is an even number. So it will be plus 1. So 1 into, again you cut these. So what I get? 4 9s are 45 minus 48, that is equal to minus 3. You see, if I interchange the row and column, the determinant value will remain same. Understood? Clear? That's with our first property. Guys, please try to get in as fast as possible. So now let's move on to property number 2. So property number 2 says if any two rows of a determinant are interchanged, then the sign of the determinant will change. Am I clear? So if I interchange any two rows or any two columns, the sign of the determinant will change. So let us do an example. The same one. Okay. The same one. It was what? Minus 3 we got. Right? Now if I interchange any two rows or columns. So what I am doing is by interchanging row 1 and row 2. I am interchanging what? Row 1 and row 2. So this is the sign of interchanging. Actually, we have already discussed in matrix chapter. So this is the sign R1 interchange R2. So what do we get? If I interchange row 1 and row 2, so this is what row 2 and this is what row 1. Now row 1 gets in the position of row 2 and row 2 gets in the position of row 1. Clear? Now if I expand, in which way should I expand this one? I will expand along row 2 because row 2 has maximum number of zeros. So expanding along row 2 will give us what? First thing, what is the position of this one? The position of 1 is A21, that is second row first column, and A21, 2 plus 1 is what? Odd number. So minus 1 to the odd number is minus. So that's why there is a minus sign, and I will write the element 1 into, now what I will do is I will cut this one and this one. 5 9s are 45 minus 8 6 8s are 48. Understood? Clear? So how much we get? 45 minus 48, right? So this is minus 3 and there is a minus, so it becomes 3. Am I clear? So by interchanging any two rows or columns, the sign of the determinant will change. This is property number 2. Understood? Now let's move on to property number 3. The property number 3 says if any two rows of a determinant are identical, then the value of the determinant is 0. Now you would be asking one question. Nobody asked me one question. Why we are doing these properties? The reason we are doing these properties, because these properties we will apply to find the value of the determinant. You see, the more properties, the better properties we know, the better or is it easier way to get the value of the determinant faster. Okay? So we can get the value of the determinant faster. You see, if I see any two rows of a determinant are identical, then the value of the determinant is 0. So if I see a determinant, suppose I say that I don't know the property of this one. Okay, now if I see a determinant whose two rows are identical, what I will do? I will try to find out the determinant. But by using this property, we can directly write the answer as 0. Now you see here, this is the determinant 112, 112, 789. Look, if we don't know the property, what we will do? We will expand. If we know the property, we will directly write the 0. So let us check whether it's true or not. So determinant of this thing will be what? Expanding along R1. So I'm expanding along R1. Here there is no 0. So we can expand along any way you can think of. So if I expand along this one, so what I get? First position, it will be positive 1. So 1 comes here. 1 comes here. Then you have cut these ones. 1 into 9. Guys, please come on time. It's already 10 minutes. Okay, so 1 into 9, that is 9, minus 8 into 2, that is 16. 9 minus 16. Now the first element is done. Now move on to the second one. Now this is what? First row, second column. So 1 plus 2, that is odd number. So that's why there is a minus sign. And this 1 comes in here. Then what I will do? I will draw this one and this one. So 1 into 9, again 1 into 9, minus 2 into 7, that is 14. Okay, then after finishing this one, we move on to the next portion. So what I get? The next one is 2. So 2, the position is what? First row, third column. So 1 plus 3, that is even. Minus 1 to the even is plus. So there is a plus sign. Now this 2 comes in here. Now after taking 2, I will cut this one and this one. So 1 into 8, that is 8, minus 1 into 7, that is 7. So this is what I get. So here, from here I get minus 7, from here I get 5, and from here I get 2. If you add them, you get 0. Understood? So whenever you see a matrix with two identical rows, the determinant of that will be 0. Even if it is two identical columns, 0. Understood? Clear? So let's move on to the next property. Now property number 4. If each element of a row or column of a determinant is multiplied by a constant, this one we have done one problem. Multiply by a constant, then its value gets multiplied by k. We have discussed this one previously. A problem there was in. If each element of a row or column is multiplied by a constant k, then its value gets multiplied by k. What was for matrix? For matrix, all the elements are multiplied by the constant k, then only the matrix will be multiplied by k. But in here what? If each element of any one row or column is multiplied by k, then its value gets multiplied by k. Understood? So that's the difference between matrix and determinants. Now look at here. Let's prove that one. If it's true or not, let's see. So A is this thing. We have already done this one before. That's the reason I am repeating this one, because we already found out. So the determinant value is minus 3. So that it will take less time to explain. Now each element of row 3 is multiplied by 2. So what I am doing is I am multiplying each element of the row 2 and by 2, right? So we have got a new determinant. It is no more a. Understood? So what I get? 14, 16, 18. So let's find out this one. By using this property, what we can say is that the determinant of this one will be twice the determinant of this one, right? But let us check. Let us expand this one. Again, we will expand along row 1. Actually, I should have written in here. So expanding along row 1. Why should I expand? Because maximum number of zeros. Clear? So if I expand along row 1, we already know this will be plus because this element. So it will be plus. It is first row, first column. 1 plus 1 is even. So then I put 1 in here. After putting 1 in here, cut these two. So 5 into 18 gives you 90 minus 6 into 16 gives you 96. So 90 minus 96 gives you minus 6. And you see that is twice the previous determinant. Am I clear? So if any row or column, if all the elements of any row or column is multiplied by a constant, then the determinant will be multiplied by that constant. Okay, understood? But for matrix it is different. For matrix each and every element has to be multiplied by the constant. Then only the matrix will be multiplied by that constant. Understood? Clear? Now we are into our last two properties. Properties number 5. Now this is one of the important properties. If some or all elements of a row of a determinant are expressed as sum of 2 or more terms, then the determinant can be expressed as sum of 2 or more determinants. So it says what? If there is, suppose I say there is one row, and in one row the elements are expressed as sum of 2 terms. Suppose here it is written a1 plus d1. Suppose it is like this, 2 plus lambda. Suppose it is like this, 2 plus lambda. Okay, in here it's 2 plus lambda. In here it is 3 plus 2 lambda. Here it is 4 plus 3 lambda. So what we can do is, I can separate into two parts. I will write here a1 b1 c1, a2 b2 c2, a3 b3 c3, right? Plus the other part, d1 b1 c1, d2 b2 c2, d3 b3 c3. Understood? So read it again. If some or all elements of a row of a determinant are expressed as sum of 2 or more terms, then the determinant can be expressed as sum of 2 or more terms. I've written 2 terms. We can write 2 or 3 terms like that. Understood? So that's property number 5. Okay. Now let's move on to property number 6. So property number 6 states that this, you should read very carefully. If to each element of any row or column of a determinant, the equimultiples of the corresponding elements of other row are added, then the value of the determinant remains the same. Listen, read it again. If to each element, now just pick this one up. Just look at this equation. I'll just make it a little bit bigger. So it says what? Read it again. If to each element of any row or column of a determinant, so I am saying that row is Ri. If to each element of Ri of a determinant, the equimultiples of corresponding elements, equimultiple means what? Same multiple, that is k, equimultiples. So k of the corresponding elements of other row is Rj, are added. I am adding both of them. Then the value of the determinant remains same. Understood? Now you see here, let us see the example. So here example is delta is given by a1, a2, a3 like this, right? Now you have delta 1. I am using this property, this condition in here. You see here, actually I haven't written here. So I will just write the condition in here. So it will be R1 implies R1 plus KR3. This is our operation which we are talking about. R1 plus R1 plus KR3. So here you see R1 is what? A1. Clear? A1 plus K into, what is the corresponding element of A1? That is C1, KC1. A2 plus KC2, A3 plus KC3. I am adding the equi-multiples of the corresponding elements. If I do that, then what happens? The determinant will remain same. Now, how can that be possible? You see, I already done this. I have already seen this one in our property 5, right? So what we can do, if by applying property 5, we can separate them. So we can write it like this: A1 B1 C1, A2 B2 C2, A3 B3 C3, and like this. Yes. Now after this, you see there is K. This row is multiplied with K, right? So I can take out K. So if I take out K, that element will be written as what? C1, C2, C3, B1, B2, B3, then C1, C2, C3. Achha, sorry, this is an error. The sign will be different. So here it will be C1, C2, C3, C2. So this will be the sign. So this is what we get, right? Now here what do we see? So here what do we see? C1, C2, C3, C1, C2, C3. We have learned that when two rows or two columns are identical, then the determinant is 0, right? So if the determinant is 0, so what we can say? That this whole part, this determinant is equal to 0 because it has identical rows. Yes, identical. Row 1 and row 3 is identical. So if this one is equal to 0, so what remains? This remains. Understood? And this is what? This one only. So if I perform this operation, then the determinant of the matrix will remain the same. Understood? Clear? Then we can start the problems. Okay?
Yes, sir.
Yes, let's start with the problem.